Okay. Yep. We start with realize about what a consumer want. When a consumer come to the market to buy goods or services, we assume that they come here to maximize their happiness. We call utility or satisfaction. Yeah. Or pleasure. So a consumer here has a well-defined goal. He know what he want to do. And a consumer try to fulfill his goal with a constraint. We call budget constraint. He cannot spend more than his income. We start with the scenario that consumer cannot borrow. Consumer has a limited resources, cannot spend more than his income. Okay. So this chapter it's about we try to offer an economic rule, economic discipline that can help this guy to make this decision, maximize his utility subject to the budget constraint. We start with a simple setup to develop our thought about this problem that he faced. Suppose we consider two goods, good X and good Y, that this guy is about to purchase. Price of good X, it's PX. Price of good Y, it's PY. And his resources, M. M represent his money income. Okay. And we notice that he is out of control for these three. He cannot influence the market price. M is the money that his parents give to him to spend on X and Y. Okay. And we put this into the academic perspective. This guy wants to maximize what we call utility, represented by U. His happiness derived from good X and good Y consumption. Okay, X may be pizza, Y Pepsi. A combination of pizza and Pepsi that this guy wants to choose to maximize his happiness. Subject to under this constraint. Yeah, constraint is the following. If we look at this, PX. Okay, let's just put this story in. X pizza, Y Pepsi. PX price of pizza times amount of pizza that he want to consume. X is a number of slices, number of pieces. Yeah. PX times X is quantity of pizza he want to buy. This term is an expenditure on pizza. Plus PY is the price of Pepsi per can. Plus amount of Pepsi he want to consume. PY times Y is expenditure on Pepsi. When we sum the two groups, two things here, yeah, it's a total expenditures that he want to spend on pizza and Pepsi. On the two goods. The equation just said, hey, you cannot spend more than your income, less than or equal to. At best, you can just spend it up equal to M. Yeah. Okay. M is income. The three variables here, price of pizza, price of Pepsi, his money in his pocket, he has no control. Parents give him only this M baht per day or per month. Price of pizza, Pepsi determined by the market. These three variables is environment that he has to deal with. Yeah. But what he can make a decision is this. number of pizza and Pepsi that he is about to buy. So his problem is then he wondering what would be the amount of X and Y, X star and Y star. Given this ideal basket do the job, utility is maximized. And he come to ask any advice from economic science. Yeah. Utility is max. There must be a basket that affordable and maximize utility. That's why we call this as consumer utility maximization problem. Problem because he must find X and Y. Yeah. Put this into the mathematical language. Do your best is about optimization when you try to do your best. Given your resources, given you this guy monetary constraint. So this problem is constraint optimization or optimization with constraint. Similar to what you just did during the midterm. Yeah. You try to maximize the points subject to 2 hours. So with your knowledge constraint, time constraint, you try to do your best. You try to optimize. Oh, optimization. Okay. Now. Okay, we work on this story with several weeks. Yeah. We will. Back to these two people here. Oh, why become nothing here? Episode 1 is about this guy's thought. Episode 2 is about another 2 guys. So Jeremy Bentham is the first person who studied utility maximization long time ago. Yeah. Okay. We call this approach cardinal approach. It's quite ridiculous when he talked about this approach with his friends during the time. He said, oh, I want to study this topic. Let's make utility measurable. Let's assume that happiness can be measured. And the unit of measurement is called utils. And he go further. The device that used to measure utility is called utilometer. Oh, he must be insane. Like we use thermometer to measure temperature. This guy dreamed of having a device that can use to measure consumer happiness. And the unit of measurement, utils. Like when you finish drinking a bottle of water, if you have this machine, it can tell how many utils you derive from this consumption. Yeah. Okay. The word cardinal means he assumed that utility is measurable. And the two persons here laugh at him later on. Hey, that's a ridiculous assumption. We don't have this. So the second approach is called ordinal approach, episode 2. The two persons here said, we don't need the ridiculous assumption like this. What we just need is make sure that this guy that we want to study his behavior, this guy can rank. If we present him 2 baskets, it's enough if this guy said, I love basket A more than basket B, I love B more than A, or A and B are equally happy. The two guys here request only this. The consumer that we want to study must be able to rank. So ordinal order, yeah. What is number 1, number 2, number 3, yeah? Which basket gives you the most happiness? Second rank, third rank, yeah. One is a Russian guy, Slavsky. The other one is John Hicks, British economist. Yeah. A bit of history here. Hicks received Nobel Prize in 1972 with his contribution to this consumer theory. Okay. Now, we start with this simple story. I want to modify this table a little bit more. Yeah. Okay. The numbers that we have here follow Jeremy Bentham. The unit of measurement is utils. Let's talk about beer consumption by this guy. First column, let's say bottles or can. Second column, total utility. Happiness that the consumption of beer delivered to him. Total happiness. Okay, how to read this? First row, no beer, no happiness. 0, 0 utils. Let's cue this. 1 bottle delivered 10 utils. If he finished 2 bottles together, TU is 15 utils, and so on and so forth. Yeah. That's second column. We call total utility. Now, the important one is this one, MU. Check. MU is a extra happiness from extra unit of beer. Let's check how to compute this. When he consumed from no beer to the first bottle, he gained extra 10. Number moved from nothing to 10. So you can say that extra utility that the first bottle deliver is 10 utils. MU from the first bottle is 10. And now, when we see this, if this guy drink two bottles, his TU is 15. We compare with the previous, when he drink only 1, oh, marginal utility is 5. He gained second bottles deliver 5 utils plus 5. Yeah. How about third bottle? Third bottle add up utility to 18. So that means MU from the third bottle, it's plus 3. The fourth one, TU is 19. The previous TU is 18. That means the fourth unit contribute plus 1. So come to here, you already see The recipe is very straightforward. Marginal utility is a change in total utility divided by change in number of bottles. Like, for example, maybe, and you can just see this. If we want to find MU from the second bottle, 15 minus 10 divided by 2 minus 1, yeah, 5/1. Use that formula. Yeah. On the top, new total utility minus O, 15 minus 10 divided by 2 minus 1. Okay. All right. Let's work on this. How about MU from the bottle number 5? Oh, bottle number 5 do nothing. It doesn't make TU increase. Then that means MU from this bottle is 0. Marginal utility from the 5th bottle is 0. Okay, number 6. What is MU? Oh, this guy throw up already. TU reduced by 1 utils. Yeah. Bottle number 7 get worse. Marginal utility from this bottle is negative, minus 2. Yeah. So let's plot then. Let's plot the two curved. Okay, visualization from this is easy. Look at this. This is a total utility. Yeah. TU utils. Since I introduce more bottles, I have to extend the horizontal. Okay. First bottle, TU is 10. We saw that. 10. TU when he drink 2 units, 15. Look at the height of the tower first. TU when he drink 3 cans, 3 bottles, 18. When he drink 4 bottles in total, deliver 19. And if he drink 5, oh, TU still 19. Yeah. Same as when he drink 4 units. If he drinks 6, TU reduce to 18. Okay. So why I have to do this? You can see the development of TU. Yeah. Okay, let's do this. When we see this TU mountain, it would say that as he drink more and more beers, total utility keep rising. But at some point, it will hit the max at some point. And beyond that point, if he continue to drink more beer, TU instead falling. when we observe this, it's rule out the possibility that TU keep rising forever. No. It's look like this mountain. Rise, max, and fall. Okay? Why they make it like a red and green here? Oh, the red one is an add up utility. Yeah. Look at the first red here. That means when this guy start from 0 to 1, add up utility is 10. MU from the first bottle is 10. When he keep drink more, we check TU. Oh, TU get higher by 5. So this rate, yeah, it's MU equal to 5. Here, marginal utility from the third bottle is 3. Marginal utility from the fourth unit is 1. Marginal utility from the bottle number 5, 0. And now it's worse, the tower becomes shorter. TU becomes shorter. That means this bottle number 6 is counterproductive, generate negative MU. MU can be negative. Yeah. The bottle number 7, even more. It's negative 2. Make the TU tower become shorter by 1 unit, by 2 units. Yeah. Then shall we just bring this rate to plot? We got this MU curve like this. Let's do more on this. So then the message from this visualization is marginal utility of beer consumption becomes smaller as he consumes more beer. The first unit give the highest MU. That makes sense. When we get thirsty, the first can of water or beer or Pepsi generate the highest marginal utility like this. Subsequent units generate lower and lower and lower marginal utility or lower add up utility. Yeah. Okay. Then it's become this law of diminishing marginal utility. Yeah, we say this. Yeah. As consumer keep consuming the goods, subsequent utility, marginal utility from subsequent units gets smaller, smaller, and smaller. Marginal utility can be positive, can be 0, can be negative. Yeah. Okay. All right. Okay. 10 minutes break. Yeah. Okay. After the break, consider a person who want to maximize his utility, total utility TU, from consuming good X and good Y. Good X, 2 baht per unit. Good Y, 1 baht. He has 9 baht to spend on the 2 goods. So to maximize utility, total utility come from TU from consuming X plus TU from consuming good Y. Subject to expenditure equal to income. Total expenditure. So as we put equality sign because this guy planned to spend all 9 baht up with these 2 goods. Yeah, he already prepared this amount to spend on X and Y. Question is, what would be the ideal combination of X and Y that fulfill this goal, max TU? Yeah. Ready? Okay. Look at this game. Okay, we have good X and good Y here. We have marginal utility from X and from Y. What we're going to do next is find, generate TU columns for good X and TU columns from good Y. Total utility. Yeah. If he consume 1 unit of X, 1 unit of X gives 10. That's marginal utility. If he consume in total 2, he must receive 10 plus 8, become 18. If he consume in total 3, he got add up from unit 3, 18 plus 6, 24. And now you can go on. Okay. Easy. Let's do TUY then. 8, 15, 21, 26, 30, 33. Example. Let's look at this scenario. If we propose, hey, you just buy this 3x and 3y. First, we have to check whether this basket is affordable. PX is 2 baht. PY is 1 baht. Okay, let's compute the budget. Yeah, let's do this computation. PX 2 baht times X plus PY 1 baht times. We can talk about this basket. This basket is affordable. 9 baht. He has 9 baht. If he consumes this basket, let's check his total utility. TUX when he consumed 3x, 24. TUY if he consumed 3 pieces of Y, 3 pieces of Y deliver 21 UTUs. Then total utility 24 plus 21, 45 UTUs. That's how we play this game. Now find X and Y that generate highest TU. For example, if 3,3 give 45 UTUs. Can you find one? There is a better one than this. Give more than 45. There is one. Okay, clock start. I will check what is the fastest this class will get there. You have to check whether money is enough. We want to spend 9 baht. Spend it up. Okay. Anyone? You got it? Okay. Less than 1 minute. 2x and 5y. What is the total utility then? 48. Okay. Uh, 2x give 18. 5y give 30. And this basket is affordable to spend up 9 baht. Utility is max. So we can use trial and error approach to come up with this answer. But approach that I'm going to offer to you is another one. Okay. All right. Okay. Just put the solution first. Yeah. There is another algorithm to find this, come up with the same answer from economic principle. Yeah. If you are ready. Move on to the next page. I just copy TUX here. And TUY. Now, you observe that there are 2 more columns. This column asks us to do this MUX divided by its own price. So just MU divided by P give this, yeah, for example, first X MU is 10, the price is 2, so 5 come from this. Okay, just an example. 5 divided, or maybe I will use the previous table to do this. 10 divided by 2, 5. 8 divided by 2. Okay. MU over P for good X. MU over P for good Y is so easy because the price of good Y is 1 baht. So same number. All right. MU over P. Then We better understand this term first before we continue here. Marginal utility per baht. When this guy spend on good X. Okay. Example, when he buy good X first unit, it give him MU equal to 10 utils. He spent 2 baht on it. Then we can say that each coin generate 5 utils. It's a MU per baht per coin. The power of 1 baht could generate extra happiness equal to 5 utils. That's example number 1. Now, example number 2. So let's say we have 2 questions that we can spend our resources on. Let's say you are doing exam. Question 1, if you complete, you get 10 points full. Question 2, you get 20 points. That's points earned. Let's assume that to get 10 full points, the estimate time that you need is 20 minutes for question 1 to get 10 points. Question 2, you might spend about 30 minutes to get the full 20 points. Yeah. If we try to compute this, point earned per minute used, we would get the calculation review that per minute spent on question 1 deliver about 0.5 point. Per minute spent on question 2 deliver about 0.66. So if we have 1 minute left, which question you want to do? Yeah, this one. Per minute generate higher additional point than this one. So if one last minute left to be spent, we must spend this one last precious minutes on the question that generate higher additional point, which is question 2.66. That's an economic rule. Now you start to get some flavor about MU over P already. Okay. Marginal utility per baht when spent on good. Now let's play this game. We will have 5 rounds. Let me check. We would have 5 slides of this. 1, 2, 3, 4, 5, and job done. Round 1. Remind ourselves first, the parameter here, px 2 baht per piece, maybe candy, py 1 baht per piece, maybe chocolate bar. M equal to 9. He has 9 baht. And the rule of the game is this. This guy will come to ask your advice. He already know that he should buy something that value for money. He must buy something that MU per baht is higher than the other good. So it worth buying. Marginal utility per baht. So this first round, his question that come to us would be, should he buy good X or should he buy good Y first? Should he buy first unit of good X or should he buy the first unit of good Y? What would you say? Then you ask this guy to look at these 2 numbers. Then, hey, when you spend 2 bahts on good X, even though you get higher, which is 10, but MU per baht is only 5. But when you spend your money on good first unit of good Y, MU is 8, but you pay only 1 baht. MU per baht is 8. 8 is higher than 5. So, argument here. Since marginal utility per baht when spending on good Y, it's higher than marginal utility per baht when spending on good X, then let's spend on good Y first. As recommendation by first Y in this round. Okay. First of Y. Okay. In the basket now, he placed 1 unit of good Y in, so just write Y. TU from this, 8. Now he enjoy 8 utils from eating first unit of good Y. He paid 1 baht in this round. Money left would be 9 minus 1, which is 8 baht left for the following round. Okay. Justification why he buy good Y first is this. We compare which good is worth for money in terms of MU per baht. Okay. Good to round 2, we use the same consideration. This guy would come to us and, hey, I already get good Y. The next question would be, should I continue to buy good Y, which is the second unit, or should I switch to buy good X, the first unit? Then we ask him to compare. You just look at these 2 numbers. MU per baht from the second unit of good Y, 7. MU per baht from the first unit of good X that you haven't bought, 5. Which one then? Still good Y. Generate higher MU over P. So argument, since 7 is greater than 5, This guy continued to buy second unit of good Y. So now he has 2 Ys in his basket. What is TU? We can just sum by ourselves. 8 plus 7, 15. Utils. In this round, he purchased good Y, which is 1 baht paid. So he paid 1 baht. Money left. Right now he has 8 minus 1 baht here. 7 baht left for the next round. Job done. This is round 2. Round 3, he would come to us, okay, I got 2 Y already. Should I continue to buy good Y, which is a third unit, or should he swap to buy good X? Let's see. Round 3. Still, marginal utility per baht spending on good Y is higher than marginal utility per baht spent on good X. He should buy good Y. Continue. Six baht left. And now basket full of good Y. Y, Y, and Y. Yeah. Okay. Round number 4. Right now, only good Y in his basket. Round number 4 is about, should he purchase the 4th unit of good Y, or should he buy the first unit of good X? What would you say? Now it happens that MU over P between the two goods equalize 5 baht per util. Doesn't matter whether he spent on good X or spent on good Y. MU per baht are the same. Check money first, how much left? 6. Whoa, money is enough. Let's buy both then. Buy 1X and buy 1Y since both generate the same MU over P. Yeah. So he will buy first unit of good X plus and the 4th unit of good Y. So it's going to be look like this. Existing 3, add 1 more Y, the Y unit number 4, plus the first unit of good X. Yeah. This is notation. I just make the color different to let you know that what he did this round is to place unit number 4 of good Y in and unit number 1 of good X. TU. If you don't want to sum MU like this, you can just go to the first table and just got TU from X plus TU from Y when he buy 4 Ys. Yeah. 21, 26. plus 10, 36 utils now. TU. This round he purchased good X cost him 2 baht. Purchased good Y cost him 1 baht. So this round he spent 3 baht. Money left, 3 baht left to be used in the final round. 3 baht left. Okay, this fourth round is about already got 4 Ys plus 1 X. So next question to him, should he buy the second unit of good X or should he buy the unit number 5 of good Y? Okay. So let's circle what he has to do. The unit number 5 generate mu over p equal to 5. Unit number 2 of good X generate mu over p equal to 4 again. 4 equal to 4. Mux over mux over px equal to muy over py. Then he can buy both again. But check first whether money allowed. He has 3 baht left. Oh, exactly. 3 baht can afford the second unit of good X and the 5th unit of good Y. So he quickly placed the second unit of X in to his basket and the 5th unit of good Y in. Now, yeah, this round he placed the 5th unit of Y and the second unit of good X like this. Job done. He already spent up his 9 baht. And he got TU equal to 48. Okay. And the basket that we found this solution is buy 2x plus 5y give the maximum of TU, which is equal to 48 utils. What is so interesting about this algorithm? Okay. Now we confirm that 2x 5y is the best. Then the rule is the following. Check this out. First of all, let's underline. He bought only 2x. Yeah, I underline this. Yeah, finish here. Use another color. And he finished with 5y. Let's underline under this. 2x 5y. The rule said to check whether the basket generates the maximum of utility, we have to make sure that once money is spent up like this, mu over p among the two goods must be equal. And this is the case. 4 equal to 4. Yeah, once money is spent up, now spend up with 2x and 5y, mu over p of good x equal to mu over p from good y. Bang. I let you see this one first. Stupid choice that we start with. This guy can buy 3x and 3y. But we know that at the beginning that we use this basket as example, we know that this one give TU only 45, short of 3. That basket give 48. This basket does not obey this rule. Once money spent up, 3 also cost 9 baht. Once money spent up, hey, something wrong. mu over p do not equal. This basket could not be the utility maximizing choice. Okay. So go back to this one to write down the rule. To maximize utility, max TU given budget constraint. He must spend such that this one is a recommendation. Yeah. Utility maximizing rule. Yeah. Or nickname is bang for the baht rule. Yeah. Okay. All right. Now, okay, let's look at this inferior choice, the stupid choice. That if this guy made this stupid choice, let's take a look. He spent his 9 baht in this way, buy 3x. Circled. How much utility he received from good X then? 10 plus 8 plus 6, 24, yeah. 3 units of good Y. 8, 7, 15, 6, 21. Okay, we confirm that if he come up with this basket, TU is 45, TUX plus TUY, 24 plus 21, 45 utils. Yeah, which is an inferior choice. In terms of this choice is not utility maximizing choice. The utility maximizing choice is 2x plus 5y. Give 48. Yeah, but this one only 45. What shall we do then? Let's see. Okay, let's say he is stuck with this stupid choice. 3. Give only 45. I call this as he is now in hell. Yeah. We are going to move him to heaven. Yeah. This is a utility maximizing basket. Yeah. Give higher TU. And before we proceed, to help this guide, let's remind ourselves that when you underline this, what did you see? Marginal utility per baht when spending on good wine, 6, is higher than marginal utility per baht when spent on good X. Write this down. MUY over PY, a per baht spent on good wine generates 6 utils. Per baht spent on good X generate 3 utils. If this guy is not insane, he should believe us. Hey, you should spend more on the good that generate higher MU per baht, which is good wine. He buy too much of good wine. He buy too little of good wine. He should buy more of good wine. And this advice something smell wrong is here. Since MUY over PY is higher than MUX over PX, what he should do is he should buy more of good wine and less of good X. This is our recommendation to him. Okay, now he's convinced. Buy more Y and less X. Now he buy how many X? 3. Okay, this guy will return good X to the seller, let's say. Now he has 3. Let's return. Okay. Okay, I will put the notation like this. He will return 1X to the seller. Let's see what will happen. Look at this table. The third unit of good X, once he returned to the seller, he would lost 6 utils because this third piece give MU equal to 6. He lost 6. Utility loss, let's call, after return this unit, minus 6. Yeah. And recommendation, okay, you already do this, yeah. Buy less of good X. He returned good X to the seller. He get 2 baht back. Since good X is 2 baht. Seller give him, okay, I give you back money, 2 baht. Spend more on good Y. 2 baht in his pocket can buy how many Y? 2Y. Unit number 4, unit number 5 together. 5 plus 4, 9. When he buy 2 units more of good Y, sorry, utility gain, we call plus 9. Wow, it's worth doing this move. Net gain will become plus 3. Which is exactly, once he followed this move, we improve his utility from this hell basket to heaven basket. Utility increased by 3 units. And once he arrived at this 2,5, we check again. This rule now fulfilled. MUX over PX equal to MUY over PY. Look at the table, yeah. 2,5 here, 4 equal to 4. Yeah, good job. So, all right. Yes. You have 2 bar left. And MU over P already equal. The rule is how to spend these 2 bar left on X or on Y. Actually, I have to look at the numbers. But the rule is that buy the one that MU over P is higher than the other one. That's the rule, yeah. But in this example may not be sophisticated like you ask, but it's already give the principle to do. Yeah. I got this question every semester. It's a good question, yeah. Today we are not going to move to the episode number 2. I will finish at this point. Yeah, for today. Yeah.